Hello everyone. So in this video I'll be showing you guys about how my robot is able to communicate with this NRF module. As you can see, this is the transmitting unit and it's our receiving unit, and we have here, this is our NRF transmitter and this is our NRF receiver. So we have used an accelerometer to control our robot. Basically, this is a hand gesture robot. So let me show you. If I tilt this accelerometer to back, then our robot will able to go back. Same with front, then with left, and same with right. So next I'll be showing you guys the circuit of this Arduino Nano, as it is really complicated here. So I'll see you.
Hey everyone, my name is Jayant and I'm a part of Team Medbot. Here I'm going to tell you more about our project and the hardware components and the communication taking place. So first, our project is divided into two units, the transmitter unit and the receiver unit. The transmitter unit has one accelerometer or a gyroscope sensor and has an Arduino Nano. The accelerometer sends the data of the movement of a hand to the Nano. Then comes the acrylic sheet from receiver unit, which is going to be the base of our project, 4 motors, 1 motor driver and 1 Arduino Uno. The main communication is going to take place between two main components, which are the NRF transmitter and receiver. Then we are going to talk about the block diagram. The block diagram consists of a transmitter part and receiver part. The transmitter part has one accelerometer, which is going to send the hand movement data towards the Arduino Nano. The Arduino Nano is going to send that data towards RF transmitter, which is going to send the data towards RF receiver through the help of radio signals. The RF receiver is going to receive that data, then it's going to send the data towards Arduino Uno, which is going to decode the data and is going to send the command towards the motor driver. Then the movement will take place. The movement will be as such as the movement of our hand. If our hand is moving in right direction, the robot will also move in right direction. So next comes the circuit part. So here I have explained the circuit of transmitter unit. One comes the NRF module, second comes the Arduino Nano and accelerometer. Here are the different pins. The NRF module has 1 to 8 pins. Then the Arduino Nano is going to have the ground, voltage, VCC, and the accelerometer is going to have these pins. Such as you can see, the VCC is going to connect with the 5 volt so that the accelerometer can get the power. The same is with all the circuits, all the pins. So here I have an image. I have an image of the circuit which is going to have the pins. The first pin is going to connect with the ground. Second is VCC. So you can take a screenshot, or you can see all the pins and the pin number which is going to connect. Next, we are going to see the coding part of our project. So now we're going to see the coding part of our project. The first part comes out to be the transmitter code. So first of all, in the transmitter code, we have added 3 main libraries which are really required for the NRF modules to work. Next comes out, we have defined 2 constant integers with the name x out and y out. They're going to be connected at pin A0 and A1. Then comes out to be the RF24 radio. So here 8 and 10 are the pins at which the RF24 is connected. Next comes out to the constant byte address. So this is the pipe address for our project, or the NRF2 modules. So here if the address is not specified, a pipe channel or the communication between two NRF modules will not work. So this is a really important part. Next comes out to be the structured data. Here we have made a structure with the variable name data, and it has 2 integers with the name x-axis and y-axis. Then the data send data starts. Here comes the void setup part. So the setup code will only run once. So this is a really big thing to be in the mind. Here the radio dot begin or the RF24 will start working. Radio dot open writing pipes. So this part will open the pipe for the parameter address, and here we have defined the address for opening the pipe. Then comes out to the set PL level. So the PL level is the power level for our RF24 module. So we have set it at the minimum, so that the transfer of data will work for a longer period of time, and it will take less power. Then comes out to the set radio set data rate. So here we have chosen the data rate to be 250 kilobits per second. It can also be set to be 0.25 bits per second. Then comes out with the radio stop listening, and then the void loop starts. So in the loop part, the code which we want to be run again and again comes out to be. Here we have defined three things. Send data dot x-axis should be equal to analog read x out. So this is the variable name for our constants. These are the constants at which are going to read the analog data sent by x-axis and y-axis. And then comes out the radio dot write, which is having two parameters, and send data and size of data. So this was our transmitter part. As you can see, you can take a screenshot of our code. Next comes out to be the receiver part. So this is the part one of a receiver code. Here we have also defined three libraries, or included three libraries in our code part. Then comes out to the pipe address. As I earlier said, the pipe address is a really important logical channel required by two NRF modules to connect. Next, we have defined some integers with variable names such as ENA, ENB, and we have connected it to pins 3 and 9. Then comes four motors with the name motor A1, A2, B1, and B2. The A1 is connected with a 4 pin, A2 is connected with 5 pin, B1 at 6, and B2 at 7. Next comes out to with the RF24 radio. So here the 8 and 10 are the pins at which the RF24 is connected. Here we have also made a structure again with two integers, x-axis and y-axis, and here the received data starts. Then comes out to be the void setup part. Here first part comes out to be serial dot begin 9600 is the parameter here we're given. So this is the baud rate. So the baud rate is really important for a serial monitor, so that the serial monitor can show us the readings taken by our project or the robot. Next comes out to be radio dot begin. Here again the pipe address is open. It is used for opening the pipe address. Next comes out to be the power level. Here we have chosen it to be the minimum, so that the data transfer or the receiver part will be on for a longer period of time, and will take less power. Next comes out the data rate. Here it is 250 again. The both of them should be equal. Then comes out to the radio start listening, and here we have defined some pin modes. So here you can see these are the integers that we have defined. Here ENA, ENB, and all the four motors are at output, so that they can give us some result. And as you can see, the motor A1 will give us output as it is going to move. So these are for controlling the motors and turning them on and off. Next comes the receiver part 2. Here it is about void loop part. So the main code which is going to run repeatedly will come out to be. Here we have used some loops, or some such as while loop and if and else if loop. Here the radio dot read. Here these are the two parameters, and receive data and size of data. And here, as you can see, in if loop, we have taken a condition which is received data dot y-axis should be greater than 400. So here the 400 is the range. 400 is the range for our received data. Here if the data that we are receiving from y-axis is greater than 400, then only the robot will move forward. And here is the code for that. If the received data is greater than 400, then this code will run. Here the motor A1 will not will be at low, so it will not run. Here the B2 will also not run. Only these two motors will run, A2 and B1. So these motor will run, making a robot move forward, and this is the speed at which it's going to run. Now comes the algebra part. Similarly, if the data we receive from y-axis is smaller than 320, the robot is going to move backward. And these two are also the same. For a robot to move left, the data we receive from x-axis should be smaller than 320, and to move right, it should be greater than 400. So these two are also the ranges at which our robot is going to move, or will consider to move. Now comes the else part. This is for stationary. Our robot will not work if it is if the code of else part will work. Here as you can see, all the motors are at low, so no motor is moving, and the ENA and B is also 0. So this was all about the receiver code. So now we are going to talk about the data structure of our project. Here the first term is the NRF modules. So the NRF modules works on basically the SPI protocol, which is serial peripheral interface. The SPI protocols usually occurs between small distances, such as 100 meter or less than that. Then the operating radio frequency is 2.4 to 2.5 gigahertz of SPI interface. The SPI interface, or the bus, is commonly used to send data between microcontrollers. So next comes the pipe. So the term pipe is a logical channel, or a data channel, which has its own physical address and can be configured. As you can see in the code, we were also using a pipe address for the main communication between RF transmitter and receiver. As you can see in this picture, we have one NRF receiver, and we have 6 transmitters. As you can see, 1, 2, 3, and 4, and 5, and 6. So this is the main receiver. So these are the data pipes which connect the receiver with the transmitter, so that the transfer of the data can occur. Next comes the SPI interface. The serial peripheral interface, as we know, the maximum data rate or the data transfer rate is 10 megabits per second, or you can say 1000 kilobits per second. So in SPI interface, we can configure, or we can change 3 parameters. Number 1 is frequency channel, then there comes output power and data rate. Here we have in our project, we have changed the output power and the data rate. The frequency channel should be same between both the SPI interfaces, such as the receiver and the transmitter. So the output power, we were using the minimum output power in our project, and the data rate we chose was 250 kilobits per second. So what is a SPI bus? SPI bus is usually a relationship between a master and slave. A master, so there can be many slaves, and there can only be master, and there is data transfer taking place between a master and a slave. In our project, there is one master and 2 slaves. Our master is Arduino, and the 2 slaves are NRF receiver and the transmitter. So the main or the unique trait of SPI bus is that in a SPI bus there can only be one master and 2 slaves, which are limited. Then comes the hardware specifications of our NF modules, which we have used in our project. This is the frequency range, maximum A data, modulation format, max output power, operating supply voltage, and all other features. So the main feature comes out that the max operating current is 13.5 ampere, and the operating supply voltage goes from 1.9 volt to 3.6 volts. So thank you. This was all from our team Medbot. Thank you for watching this video.